Hello friends, in today's question, a wave disturbance in a medium is described by the equation y of xt, which is equal to 0.02 cos of 50 pi t plus pi by 2 multiplied by cos of 10 pi x, where x and y are in meter and t in second. And we are supposed to find out the position of, or rather we can say it is a multi-correct option. So we have to find out the places where node occurs, antinode, along with the speed as well as the wavelength. So the given equation consists of two parts. One is our cos 50 pi t plus pi by 2, and the second part is cos of 10 pi x. So this part cos of 10 pi x, it is called as a special component, or we can say it represents a space dependent part, whereas the first part, that is a cos of 50 pi t plus pi by 2, it represents a time dependent part. So we are going to use two parts independently and find out the speed wavelength along with the position of the nodes as well as antinodes. So we are going to start with the given equation. So we are given that the given equation, which is our y of xt, is equal to 0.02 cos of 50 pi t plus pi by 2 and multiply by cos of 10 pi x. So from here we can say that our A, which is our amplitude, it is equal to 0.02, and like I said, the given equation consists of two parts. You can say the first part, which is a cos of 50 pi t plus pi by 2, represents the time dependent part. It represents time dependent part. And the second part, which is our cos of 10 pi x, this represents the space dependent part. Space dependent part, or sometimes it is also called a spatial part. Spatial part. So this is our first component, and this is our second part rather, and we are going to make use of first part in order to find out the wavelength as well as speed. So you can say from first part, which is our cos of 50 pi t plus pi by 2. From here we can easily find out the wave number, which is represented as k. So therefore we can say that k, which is the wave number, will be equal to we are going to use the second part, my mistake, from second part, which is our cos of 10 pi x. So we are going to get the wave number, and the wave number will be equal to 10 pi, which is equal to our 2 pi upon lambda. here pi and pi cancels out, and this gives us a lambda is equal to 2 upon 10, which is about 0.2 meters. And now we can find out the wave speed, which is our v. Wave speed v, which will be equal to omega upon k, and our omega is our, from first part we can find out our omega. You can say from first part, which gives us cos of 50 pi t plus pi by 2, this gives us that omega is equal to 50 pi. So therefore we substitute the value. We already know the wave number as well as the omega, so therefore we can say that our v, wave speed omega, is our 50 pi and wave number is our 10 pi. Pi and pi, and this goes by 5. So we can say from here that our wave speed v is 5 meter per second. Next, we are going to find out the position of nodes and antinodes. Nodes and antinodes. And for this, we are going to use the cos of 10 pi x, that is our second part. So let us start with our node part. We can say that nodes occur where the spatial part with special part of the wave which is our cos of 10 pi x equals to 0. Equals to 0. So we can write it in the form of the equation. We can write this as cos of 10 pi x will be equal to 0. Or from here we can say that our 10 pi x will be equal to 2n plus 1 multiplied by pi by 2, where n is equal to 0, 1, 2 and so on. So we can just solve it for x. So we can say that our x is equal to 2n plus 1 divided by 20. And once again our value of n is 0, 1, 2 and so on. Therefore we can write that nodes occurs at x is equal to, we just put value of n 0, 1, 2 and so on. This gives us 1 upon 20 meters, and this is 3 upon 20 and so on. And let's find out our antinode now. So we can say that antinodes occurs where cos of 10 pi x reaches its maximum value, or we can say that our cos of 10 pi x will be equal to plus minus 1. So therefore we can say from here that our 10 pi x is equal to n pi, where value of n is our 0, 1, 2 and so on. So therefore we can write that our x is equal to n upon 10, value of n is our 0, 1, 2 and so on. So now we put the value of n one by one and we can write that our antinodes occurs at x is equal to 0, 1 by 10 meters, 2 by 10 meters and so on. So we can just compile all the results. We found out that the wavelength, that is our lambda, is our 0.2 meters. Wave speed, that is our v, wave speed which is v, is our 5 meter per second. Nodes, occurs at x is equal to 1 upon 20 meters, and next is our 3 upon 20, so on, and finally we have our antinodes occurs at x is equal to 0, 1 upon 10 meters and 2 upon 10 meters and so on. So if you check the options that are available to us, we have waves length of 0.2 and wave speed of, so wavelength of 0.2 is correct. Wave speed is of 5 meter per second. This is also correct. And node at antinode, it is given a decimal form. Let's convert it into the required decimal form. So we can say that our 1 upon 20, this will be, you can just convert into decimal form. This will be coming as 0.05 and this is our 3, so this will be coming as 0.15, and similarly for antinode also, so we can write this as in the form of decimal 0.01, sorry 0.1, and this becomes 0.2 meters and so on. So we are having the nodes at 0.15 and antinode at 0.2. So we can say that node is at 0.3 meter. Yeah, we can just elaborate it more. One second. So we have node at 0.15 meter. Yeah, so we have node at 0.15 meter. So this statement is correct. And anti-node at 0.3 meter. And we have to find out anti-node at 0.3 meter. So we have to just add one more here. That is our 3 by 10. And that will be coming as 0.3 meters. So this option is also the correct one. So anti-node is at 0.3 meter. So this option is also correct. So all the options A, B, C and D are correct. So you can say options A, B, C and D are correct. So this completes the question. Thank you.